As we start our last video on factoring polynomials, I wanted to start by bringing the flowchart up. In this flowchart, we started right here, and anytime you factor a polynomial, you look to see if there is a GCF. That was in lesson IA8. Also in that same lesson, we talked about what if there are 4 terms. If there are 4 terms, then you use a process of grouping. In the next lesson, in IA9, we talked about factoring trinomials with 3 terms, and we spent most of the lesson on trial and error, but we did also talk about perfect square trinomials. Finally, in our last lesson, we talked about factoring binomials with 2 terms. We saw difference of squares, difference of cubes, and sum of cubes. So in the lesson we're going to do next, we will probably be combining some of these. GCF, and then maybe it will be the difference of squares, or GCF and then it might be trial and error. So we'll see in this next lesson. Our instructions in IA11 on factoring will simply say factor the expression completely. It will not give any indication as to what kind of polynomial it is or what factoring technique I should use. Alright, so the first thing I look for is there a GCF? So look at first term, second term, however many there are, and yes, I see a common factor of 7, and I also see a common factor of x. So I'm going to factor out 7x, divide by 7x, divide by 7x. You may not need to write that down. You might could see that in your head. 7x goes in there, x squared times, keep the minus sign. 7x goes into 7x one time. Never immediately think that you are done. We did GCF. But next I'm going to look at this polynomial to see if it is still something I know how to factor. And it's a binomial factor on its own, and it is a difference. There's a square, and there's a square. So the factor in parentheses can go further. I will keep the 7x. Don't lose your common factor if you had one. And then, working just on the trinomial part, 1 plus, 1 minus, x plus 1, x minus 1. All of this is your factorization for the original polynomial. All right. Oh, so the 2 factoring techniques I used: first, GCF, second, difference of squares. Let's see what number 2 holds for us. Factor the trinomial completely. I look at it, always looking for a GCF, and I notice that all of the coefficients are even. So I will factor out a 2. Divide by 2, divide by 2, divide by 2. That gives me x squared plus 11x plus 18. Now I will be keeping the 2, but this trinomial factor looks like trial and error. So I had a GCF, and I believe that I'm going to have trial and error. So keep the 2. That's a mistake students make sometimes, is they forget or leave off a GCF that they found. 2 parentheses, I'll review the rules for signs. If the last sign is positive, then you will either have plus, plus, or minus, minus in order to get that plus, and the middle term tells you what to choose, so I will choose a plus and a plus. To get x squared, I need x times x. To get 18, I will either have 1 times 18 or 2 times 9 or 3 times 6. And because the leading terms just have ones, I just need to look at these and see which one gives me a sum of 11. And it's 2 and 9. You should check your problem. I'm not going to check it in the video, but you would check this product by FOIL to see if you get this. Then you would distribute the 2 to see if it takes you all the way back to the beginning. Let's look at number 3. Do you have a GCF? And the answer is, the answer is yes. There is a 5. So I will factor out a 5. Divide by 5. Divide by 5. That leaves me with x to the 4th minus a 1. I see a binomial. X to the 4th, because the exponent is even, is a square. 1 is a square. So this is the difference of squares, abbreviated. So I'll keep the 5 and factor the difference of squares, 1 plus, 1 minus. The square root of x to the 4th is x squared. The square root of 1 is 1. I have a 5. I have an x squared plus 1, and remember, if it's the sum of squares, it's done. It's a prime factor. But the last binomial factor is still the difference of squares. So I'm going to bring down the 5, bring down the x squared plus 1, and factor this binomial into its factors. X plus 1, x minus 1. I could not do that with this factor because it was a plus. You will need all of this as your factorization for number 3. So I did GCF, difference of squares, twice. Let's look at number 4. It's been a few lessons since we looked at something like this. I do look for a GCF, but I don't have one. So the next thing I do is count. There are 4 terms, which means I'm going to start with grouping. First group, second group. In just the first group, is there a common factor just between these two? The answer is yes. The common factor is x squared. You'll divide by x squared, divide by x squared. X squared goes in there. You'll use the quotient rule. You end up with x. Divide here and you get minus 4. That's for the first group. Second group, please remember that the sign of the factor, the GCF in the second group, always has the sign of the sign in front of that term. I see a 9 in those, so my GCF is going to be a minus 9. So I'm going to divide by negative 9, divide by negative 9. Negative divided by negative is positive x. Positive divided by negative is negative 4. Now I have a common binomial factor, and I'll put it in front as x minus 4. My leftover factor is x squared minus 9. Now when we did the lesson on grouping, that's all we ever had to do. But look at what you've created. A binomial factor that cannot be taken any further, but a binomial factor that happens to be the difference of squares. Crazy abbreviation. I'll keep my x minus 4 and 2 parentheses, 1 plus, 1 minus, x plus 3, x minus 3. So we did grouping and we just happened to get the difference of squares as one of our binomial factors. Let's look at number 5. All right, let's see. Is there a common factor? Yes, 7. If you divide each of these by 7, you'll get x squared minus x minus 12. Well, this trinomial looks like what I could do. Let me go ahead and say GCF. I'm going to try trial and error. Keep the 7. Let's talk about the signs. When the last sign is negative, it is always 1 plus and 1 minus. I need x and x. Because the outer and the inner signs are different, I'm looking for factors of 12 that have a difference of an implied 1. So is it 1 and 12, 2 and 6, or 3 and 4? And it's 3 and 4, and you put the larger factor where the sign of the middle term is. So the 4 goes here and the 3 goes here. You must include all of that as your factorization. All right, let's look at number 6. Factor this completely. Well, I see a GCF. I see 3x as a common factor of those. So I'll divide by 3x, divide by 3x. That will give me x squared, using the quotient rule with those exponents, minus a 9. Look at the binomial factor. Is it something you recognize? I hope you see it as the difference of squares. So keep your 3x, factor x plus 3, x minus 3. And you need to write all of that down. Number 7. There is no GCF, but it's a binomial. So we only know 3 kinds of binomials to factor. We have difference of squares. We have sum of cubes. We have difference of cubes. Now, although these quantities, x squared and 64, are squares, this guy right here is a sum. The sum of squares is prime. There is no factoring to be done. Let's move on to number 8. Well, immediately I see 4 terms, so I'm going to be doing some grouping. I do take a moment to look, was there a common factor to all of those terms? And the answer is no. So first group, second group. In the first group, common factor is x squared. This looks very familiar. Let me look back. Yes, it's familiar. It's slightly different, but all right, x squared. Use the quotient rule to get x, divide there, and get minus 3. Bring down the minus sign. The common factor is 9. It needs to be minus 9 because of that minus sign right there. So you're going to divide by negative 9. That gives me x, and that gives me plus 3. And go back over here. I don't know if I said it right or wrong, but that is a plus 3. All right, my common binomial factor is x plus 3. My other factor is made up of an x squared and a minus 9. I take a look at this and say, oh, That is the difference of squares. You'll keep this factor, x plus 3, and then factor this one further into x plus 3 times x minus 3. So there was grouping, and then there was difference of squares. All right, I believe this is our last one in this lesson. All right. Look at this. The first thing you always think about is GCF. Well, both of these have powers of y. You always take the lowest power. So take y squared out of those. Y squared, use the quotient rule. You get y to the fourth. Here you'll have a minus 16. I might be done, I might not. Take a look at the binomial. Because that's an even exponent and that's a perfect square, it is the difference of squares. So I'll keep my y squared. The difference of squares always factors into a plus and a minus. The square root of y to the fourth is y squared. The square root of 16 is 4. I have the factor y squared. I have the sum of squares, which means I can't do any further. Oh, but I have the difference of squares here. So I'm going to keep y squared. I'm going to keep y squared plus 4 because it is the sum of squares. But I'm going to factor this, because it's the difference, into the sum and the difference of the square roots, which means the square root of y squared is y, the square root of 4 is 2. You must have all of that written down to get this correct. And let me add that we did difference of squares a second time. So the value of this lesson was to think about all of the different things that are in the factoring flowchart, asking yourself questions in the order that you see them. I think the only thing that this lesson did not review was sum and difference of cubes. I'm sorry about that. It really should have. As a matter of fact, I think I'll make one up. What if I have 3x cubed plus 375? And I ask you to factor that. Well, it turns out that there is a GCF. 3 does go into 375. I just made this up, so it's not overly creative. But 3 is a common factor. Divide by 3, divide by 3. That gives me x cubed plus 125. Keep the 3, but this binomial, there's a perfect cube, and 125 is a perfect cube. And it doesn't matter if it's sum or difference, we can factor either one. Small parentheses, large parentheses. In here go the roots. X, keep the sign, plus, cube root of 125 is 5. To build this one, it's square the first, change the sign, product, square the last. And I will just tell you, in case I didn't emphasize it before, the trinomial that you get when you factor sum and difference of cubes looks like it could be factored further, but it can never be. It will always be prime, which means finished. So I just made this one up because I didn't have one in the assignment. So by the time you finish this lesson, I hope you feel like you can do a decent job of factoring.